Okay, system is filled up. Hang on, turn these fans off. We got a switch right there. We got a light switch and a fan switch. And the lights lighted up pretty good in here. So anyway, tank is full. That is normal operating level right there. And it is recirculating. I'm adding water right now. I'm trying to figure out the overflow. That overflow right there is set. I don't know if you can see that. It's just an open pipe. So there's a 3-inch pipe that goes through the bottom of the tank, and then the 4-inch pipe on the outside has the holes and the screens down at the bottom to keep the little fish from going through. And then there's, of course, there's holes down there in the 3-inch pipe that lets the water out. So that is, I'm adding water right now, but that is right about the normal operating level. The water goes through the bottom of the tank, comes off the bottom of the tank and goes through the bottom, and it goes underneath the tank up into there. You can't see, but it comes out of our frame and goes into the side of the radial flow filter. That's the blue barrel, and you can see the water is welling up through the center pipe there. So that water is coming from the tank. Normally, the radial flow filter has a lid, and it looks like, let me set this down over here. Looks like that. So there's a lid for the barrel. That handle has holes drilled in it, so it doubles as an air vent, so you don't get an airlock. And then there's this shroud that has vent holes in it, and then that shroud, when it goes on the filter, sits down over top of that pipe that's got the water coming up. So that shroud forces the water to go down, and when the water goes down, of course, the solids go with it, and the solids continue on to the bottom, and the clean water comes up at the outside of the shroud. And it's not here yet. I got to get a Uniseal. Should be here next week. But there'll be an outlet on this tank that will set the normal operating level right about here, and it'll come out and drop down and go underneath and run all the way back to the back of the greenhouse, and then through that wall right there. And that goes to the sump. And then the sump, of course, has a pump in it, and it pumps the water back up. It'll be along the pipe, runs along here, right to here, where there'll be a flow meter and a valve to adjust the flow. And then that will go into the fish tank in 2 spots, right here and right here. So that's the first loop. That's the water circulating. Let me check my level here. Oh, come on out of there. Okay, so that's getting pretty close. I'm going to keep adding some water. What I'm trying to do is establish the normal operating level, and I want the normal operating level to be just below the lip of that overflow. And as you see right here, this hose I got clamped on here. Okay, we're back. I don't know why my phone quit, but anyway, I was talking about that hose. That hose on the pipe there, or on the side of the tank, is coming from a pump which I have down inside there. It's just a 1,200 gallon per minute pump I had for some other purpose. I don't know. I had it for a couple of years. But it's taking water out of this flow filter, this radial flow filter, and pumping it back into the tank. So it's simulating that loop that we're going to have from the sump tank back into the fish tank. And I did a bucket test a little while ago. That's flowing about 13 to 15 gallons a minute, which is about what we're going to expect to put into the tank from the sump. That's normal level, or that's normal flow rate. You want to turn the tank over, the fish tank over once every hour. So 625 gallons, you want to run a little more than 10 gallons a minute normally. And when that water comes back from the sump, it's going to go, like I said, through a flow meter there with a valve to adjust it. And it'll go into two nozzles that'll go right there and about right there somewhere. And those will have venturis on them, and they'll be sucking air in. So the air will be entering the tank downward at an angle in two places with air bubbles going in to help aerate the water. But that's the purpose of that is to keep this water in a slow circulation direction like this. And what we're trying to do is force all the solids, the fish waste, into the middle. And that's, of course, that's where the water goes out. So you want to keep the solids moving along the bottom of the tank and keep removing them, getting them out into the radial flow filter. And because those solids are heavier than water, they do sink. They will go into that radial flow filter, sink to the bottom, and be collected down at the bottom. So the way the radial flow filter works is there is a grid down there in the bottom. You can see it. They're just 3/4 inch pipes. They have 1/4 inch holes drilled in them down the bottom. There's probably 10 or 12 holes in each branch. There's 4 branches there. They all muster together and come out that 3/4 inch pipe right there and come out the side. And they can go 2 directions. You can take them through this yellow valve right to a 5-gallon bucket. That's set up to where that you can get a 5-gallon bucket underneath there. So you can drain them fish waste and then stuff you don't want in there. You can drain it out directly into a bucket. But normally you won't do that. Normally you would take those into this tank. This is a mineralization tank. The mineralization tank, you go outside and empty that once a week. I'm guessing once a week, maybe a little more, maybe, who knows. Outside here, there is a drain valve on the side of the greenhouse. And I did a test. That valve, excuse me, in that pipe, you can drain 4 5-gallon buckets of water out of there, out of the mineralization tank. So that's where your waste is ultimately going to leave the system. And you can take that out and dump it on trees or on plants or on flowers or whatever. It's great fertilizer. But that waste has been in that mineralization tank for a week. And in the mineralization tank, it's not here yet, but there's going to be an air line going down. There'll be air stones down there. And that's going to keep this area in this mineralization tank aerobic. And there are aerobic bacteria occur naturally, and you don't have to put them in, but they will break that waste down and they'll make the minerals, the zinc, the copper, the iron, the phosphorus, the potassium, things the plants need. Those bacteria will break that waste down and put those minerals into the water. They free them up. And on the line that comes across here going to the fish tank, the water line going to the fish tank from the sump, there'll be a small tap right here with a small valve, just a little 1/8 inch bleeder valve. It'll put water into this tank while it's working. And this pipe right here is a still well. This section over here is very active, it's churning up, it's aerated, it's bubbling. But this still well, it has small slits. It goes all the way to the bottom, and there's some small slits down there. So the water that's in here will be very slow moving. It's called a still well. The water is still. But because we're adding a small stream of water here, this water comes up in this still well and goes out that tap right there, and it's not hooked up, but there will be a tube that takes that water flow back down to the drain and adds it to the system. So that's how you get your minerals back out of the fish waste. And then once a week, like I said, you dump this and you empty that, and that takes all that fish waste that's been worked on for a week out to the buckets. That leaves this tank empty. So then you open up the red valve, and it takes the fish waste off the bottom of this tank that's been collecting for a week into here. And then that sets you up for the next batch to work for a week. So that's how you get your minerals back. And then, like I said, you always have the option to just drain fish waste out if you want to. But normally you want those minerals, so those will come back. But that's how the system works. So this is what's called the split flow system. There's two loops of water. There's two flow loops. One is from the sump to the fish tank and back. So that loop is running. When the water comes in through the back wall, it splits. It goes to the fish tank, loop 1, and it also goes to 4 prongs, 4 feeder lines. This line will come up here and feed all of the lettuce rafts, the NFT channels that we're going to have along here, and strawberries up in the top. It'll also come down, another branch will come down this side of the support columns and feed 7 grow beds that are right in here. There'll be another branch on this side that will come along here and feed 8 grow beds along here up the middle center line. And there will also be a line over there that runs up that wall to about right there and feeds another 8 grow beds that are going to be built along that wall over there. So 23 grow beds. They are 40 inches by 52 inches in size, and they're about a little over a foot deep, filled with gravel. So most of your water, about 1/3 of your flow goes to the fish tank, and 2/3 of the flow goes to your grow beds. And then those grow beds have external bell siphons, each one, and they will drain into the drain system, which goes back there to the middle, joins up with that fish tank waste, or the fish tank flow coming out of here, which, like I said, isn't there yet, but it'll be right in there. Drop down, go back there, and all the drains join up and go out to the sump tank, which is a 500-gallon tank, which is buried in the ground, or will be, and has the half-horse pump in it. And that system, or that pump, between that line and the 4 lines going to the grow beds, that's a total of about 3,600 gallons an hour, or 60 gallons a minute, call it. So that's how the system will work. Still waiting on evaporative cooler media to build those out. Still got to go inside and pull the sliding glass door out of the house, which right now is between the house and the sunroom. Sunroom used to be a porch, so we don't need that sliding glass door in there anymore. So I'm going to recycle it, and we're going to put it right here. So that's another job I got to work on. And then I'm going to start this week digging that sump out there. I've got to dig a hole 5 foot deep, 5 feet wide, and about 12 feet long, I guess. So shouldn't be too hard with a tractor and the trencher, so we'll see. But anyway, I'm going to let this system run overnight. That's a continuous duty pump down there. Just a little giant 1,200 gallon an hour. So I'm going to let this circulate. Have had no leaks anywhere except right here. The white PVC to the black high dollar bulkhead fitting has a slow drip about once every 10 or 15 seconds, which dress. That was not the one I was worried about. The one I was worried about is the $7 rubber O-ring fitting that went through the bottom of the tank, which I was pretty sure was going to leak, but so far hasn't had one single drop come out of it, so go figure. Anyway, I will sign off and get these videos uploaded, and I will talk to you later. Bye.